Okay. Now we'll start chapter 9, which is introduction to data link layer. So we will talk about introduction. We will talk about the data link control, DLS, DLC, and media access control, MAC. And also the link layer addressing, address resolution protocol, ARP. The same figure for each layer. You will find it. Just take a look at it. It show you the general overview about the network data link layer. Here it says illustrate the concept about nodes and links. Okay, nodes and links. So, for example, here we consider the PC and the routers as nodes in general, and we call the link between them a link. So link. So that's a link layer. It's like dealing between at the level of node to node, and also it's point to point, of course. So from here to here, point to point, point to point, point to point, and so on. And each of them we call them node, whether it's the sender or receiver or it's the routers. We call them nodes, and the thing between them is called link. So the services of the data link layer is located between the physical and the network layer. Okay, as we know, provide services to the network layer. Okay, and it's receive services from the physical layer. Okay, the duty scope of the data link layer is node to node, like here, node to node, node to node. Okay. When a packet is traveling in the internet, the data link layer of a node, host, or router is responsible for delivering the datagram to the next node. So just delivering here to here and here to here and so on. In the path, okay. For this purpose, the data link layer of the sending node needs to encapsulate the datagram received from the network into a frame. So as we know, if you go from bottom to up, you will encapsulate. Yeah, you will encapsulate. No, the reverse. Uh, from top to bottom. So you will encapsulate. So here it's received. It received from a network layer. It received the data. Then it will encapsulate it to make it as a frame. Okay. And in the receiver side, it will decapsulate. So from bottom to up, it will decapsulate the things that it will encapsulate from a frame to a datagram. Okay. What he explaining here, just like the data frame going from data link to another data link to another data link. So it just from node to node. Nothing, nothing hard here. Okay. And the services of this layer is framing, flow control or error control, congestion control. And we have two sub layers in this layer. The first layer is data link control DLC, and the other is the media access control. So whenever we will deal with the broadcast link, you will have the two layers present at a time. But whenever you have point-to-point link, you will have only one layer of them, data link control sub-layer. So you will have only the first one, data link control. But whenever you have a broadcast link, you will have the media access control. Point-to-point, just sharing between two things. A broadcast, maybe one too many. So maybe it's 3, it's 5, it's 10, and so on. Link layer addressing, IP address are the identifiers as the network layer. However, in connectionless inter-network, such as the internet, we cannot make the datagram its destination using only the IP, as we saw before. Only IP is not enough, so we will need the physical address, which is called the MAC address usually. So the source has defines cannot define only, yeah, as we said. So we'll have another addressing mechanism, which is in the link layer address. Yeah, it's called link address or physical address or MAC address. So you will need, they will work together. The IP and the MAC work together. One of them cannot do anything without the other. Okay, at the general level, of course. So the IP to define the source and destination, but the MAC in order to travel from a node to node. We'll see here through an example. So here we want to go from Alice, the sender, to the receiver, which is Bob. Uh, Now, the IP here is the N1 and N8. And as you can see, okay, it identifies this. From N1, I'm going to N8, and this is the data that I'm taking. So already the IP identifies the sender and the receiver directly. But we have the intermediate points that I can't reach directly from node from Alice to Bob with the IP address only, which is here in this case N1 and N8. I need also other address called MAC address, which represent here by L, in order to get to, because it's the MAC address help me with the intermediate nodes like this one and this one and so on. So the IP will remain constant among all the frames. Okay, this is called a frame because it's encapsulated in the, it's getting encapsulated by the link layer. When I received it from the network layer will give me the IP from the source and destination. I will get the, from the network layer, I will get the datagram or as like this. Okay, and in the link layer, I will make the frame, and I will encapsulate the whole thing that I have received from the network layer. And in the header, I will have the source and destination MAC address. And in this case, it's L1 and L2. You will say why it's reversed, okay? Why L1 and L2 are reversed? It should be here like L1 and here L2, like the IP address. I will tell you no. There is a rule like in the IP address, yeah, it should be like sorted, okay? So you start with the one that is coming from, and you end to the one that you are going to. So it's here. It's coming from N1, so I put it at the left side, and it's going to the right one, so I will put it in the right, the N8, the destination. But in the MAC address, you will reverse it. So the destination will be at the left, and the source will be at the right. So here's the source, L1, the MAC address. So I will put it at the right, not the left. And in the destination is L2, I will put it on the left. Unlike the IP address, I will put it in them in order. So the source will be at the left, the receiver or the destination will be on the right. But in the MAC address and the frame, it will be reversed. So you will have the source, the destination first, then the source. So that's why it's reversed here. Not L1 and L2. It will be L2 and L1. So just memorize it. Okay. Now with this MAC address, I reached from here to here. Now I have L4 and I want to reach to here, the R2. So I need L5. So the destination and the source also reversed. The destination comes first, then the source, and this stay as this. The IP won't be changed, and the datagram won't be changed. Here is the only the job with the MAC address, because the IP already identifies the starting and the ending point between Alice and Bob, but we are needing now the MAC address in order to reach between the intermediate nodes. Okay, so you will have L5 and L4 here. You will put them here, the destination, then the source. Now I have reached here. I want to reach to the final thing, which is Bob. Now I need L7 and L8, and it will be reversed. L7 and L8, the destination, then the source. Okay, it's coming from here to here. Now the final one. I hope it's clear. So just the concept here that the IP and MAC address work together uh, in order to reach. So that's why you have two lines here, the gray line and the blue line. We have three types of addresses. The unicast address, which means one-to-one communication. The multicast, one-to-many, so maybe 1-to-2, 1-to-4, 1-to-5, etc. And the broadcast, which is one-to-all. So whatever you have in the network or the communication, it will select them all. But here many. So let's say we have 5 nodes. Maybe it will be 1-to-4 or 1-to-3 and so on. But when I say broadcast, it will be 1-to-5. So it will select them all in whatever in the communication. Okay. So address resolution protocol, RAP. It's the thing that I guess it's embedded with the network layer. Yes, it's embedded with the network layer in order to provide the IP address. I guess yes. Let's read. It has the IP address of the receiving node. Okay. The IP address of the next node is helpful. We need to link that to address. it belongs to the network layer. So the ARP belongs to the network layer. But we discussed this in this chapter because it maps an IP address to a logical address. So it will tell the link state about the IP address. So this is the job of the ARP. Uh, Before sending the data to the link state layer from up to down, it will tell it also about the IP of the sender and receiver. So RP accept an IP address from IP protocol, maps the address to the corresponding link state address, and passes it to the link state. So here we have the network layer. At the end of the network layer, when I'm about to send my data to the lower layer, which is the link state, I will provide also the IP address to the link state layer. So here we have two types of the ARP ARP operation. The first is called the request. So I'm sending the request is sent as a broadcast, which means I'm sending from system A or whatever system to all of the nodes. So here you can see the arrows, it goes to everyone. So the request go for everyone. But when I'm receiving the reply, it will be unicast, which means it will be one connection only, because I get now when using the ARP operation, when I'm requesting, I'm saying like, which one of you is the one that I should communicate with? So it will come here, it says, oh, I'm not the one, leave me, I'm not the one. Oh, here will say, system B will say, oh, I am the one, you should communicate with me. That's why the reply will come from only one device, so because I want to communicate with only one device, okay? Not all of the devices. That's why the request is broadcast, because I don't know which device I should communicate with, so I will ask everyone, but the reply will come only from one, because I am the node that you need to talk to me, or you need to do your job to me. So this is the ARP operation. It helps the link address. Yeah, it's the link address layer in order to identify the uh, receiver device. Okay. ARP packets, it consists of hardware type, it's LAN or WAN, and protocol type, which is network layer. Operation, the request is operation by one and the reply by two. As we said, the request is broadcast, the reply is unicast, which mean one to one, the broadcast, which mean one to all. Protocol links and hardware links, you have the source protocol address, source hardware address, and so on. Take a look at the ARP packets and try to understand it. And it's, of course, it's 32-bit. The internet, for our example, just point-to-point concept. He's explaining here that it's a one-to-point network. I don't know. Yeah, that's it. Here he's explaining. Oh, now I understand. Okay, he will explain this in more details now. So here is he's telling you that I get the data and I get the IP, which is NA, and the destination will be NP. So I want to get from Alice to Bob. I will get the data and the source IP and the destination IP. I will create the datagram. It's created by the network layer. So the network layer create the datagram. It will have the source and the destination IP address. Here it's telling you about the forwarding table, about the NP. It will take the ARP, and it will give back the corresponding address, okay, so that it will be provided to the link state. So here the ARP is providing the L1, which means that the destination IP, the destination MAC address. So you get here the destination MAC address, and of course the source MAC address, you already know it, or you will get it by the same way, the ARP, which is the LA, okay. And now he will create a frame. It's the job of the data link layer. It will create a frame, and here the network layer job data frame is still the same. You have the IP for the source, IP for the destination, and here is the reverse. You have the source, then the destination, then the source. Then it will go to the physical layer, and as a signals, it will go to R1, which means we go from here now to here, R1. What has happened to the R1 now? Yes, it will get the from Alice, it will get that data. It will go to the physical layer, of course. It will come here. Now we are doing the decapsulation, as we said, from bottom to up, it's decapsulating. From up to bottom, it's encapsulating. So here it's the decapsulate, so it will remove the header of the frame. It will be now a datagram as like this. It will go back to the network layer. Now it will ask for the from the forward the ARP for the R2. It wants to know the physical address. Not the physical, yes, the physical address, the MAC. It want to know the physical address in order for it to go from this R1 to R2, and the IP will stay the same. As we said, it will remain constant because we already know, like, the source is the NA, which is Alice, and the destination is Bob, which is NP. But we only care now about the MAC address as we described in the previous example here. Same concept. The IP stay the same. It's just another example. Okay. Yes. So now when I get the L3 and the L2, we know now that I'm currently in L2, and the L3, I get it from the ARP. So here I will provide it to the link layer. It will give me here the destination, then the source. Here the source, then destination of the IP. I'm coming back to a frame. I'm sending now to the physical layer. The physical layer will send it as a signals to the R2. So now I'm here. Let's see. Now when I reach here, I will decapsulate, remove the header. I will come to the datagram again. I will ask from the ARP what is the next MAC address, which is L4 or LP. I'm currently in L4, so I will have the L4 and LP to the data link layer. I will put it in the header, the destination and the source, and here the IP remains the same, and so on. It will go now to the Bob's computers. Now it will go to the Bob, and by that, when Bob receives it, same thing. He will decapsulate. It will get the he will get the datagram. He will also decapsulate it, and it will go to the other upper layer until he reach to the point that he will get the data. So here he will get the data. Okay, after decapsulating the network layer, the datagram, and also the frame, step by step until he reaches to the top, he will get the data. Okay, which is at the application layer, after the application layer. Okay, so that's it for chapter 9.